welcome, and thank you for joining us for Sean Downs' talk, Velocity versus Volume. Sean Downs is a theoretical physicist practicing as a data scientist at Expedia. His present work involves fun projects like building learning-based recommendation systems to aid Expedia customers and suppliers. He has also spent a lot of effort on marketplace and auction design, building incentive structures to promote and reward supplier behavior that leads to great customer experiences. Please welcome Sean.
Thanks very much. Thanks for sticking it out and being here at the very end of another great conference. And thanks, Doug and QWell folks, for inviting me out. I'm a data scientist. I build models. I'm going to talk to you about one of the kind of data products, model recommendation system that I've been working on lately that I'm pretty excited about. But because I build models, I like to think about things in terms of models. So I'd like to kind of start today off with something of a parable, which I will hope kind of will set the scene. So apologies, this is kind of an academic joke, but I hopefully think the story should there's a story behind it, should tell itself. So this is the parable of the engineer, the physicist, and the mathematician. So there's a building, and in this building there's a room. And in this room there's a fire. Next to the fire there's a bucket of water. Okay, engineer walks into the room, sees the fire, sees the bucket, picks up the bucket, throws the water on the fire, puts the fire out, walks out. Engineer walks into the room, sees the fire, sees the bucket, stops and thinks for a bit, picks up the bucket, walks about 2 feet from the fire, tilts the bucket to 12.5 degrees, and walks counterclockwise about 2 rotations per minute. Takes about a quarter worth of water in the bucket to put out the fire. Puts it out, puts it down, leaves the room. Mathematician walks into the room, sees the fire, sees the bucket, thinks, sees that a solution exists, and walks out the door. Right? So I'd like to introduce you to some of the characters that we'll be seeing who participated in this little parable. One, Andy, the engineer, right? Indara, the physicist, and Greg, the mathematician. And so I realize we're in a kind of a business context. So in the business context, we're thinking more in terms of, well, engineers are engineers still. The physicists become data scientists, right? And the mathematician is kind of like the architect or the principal X or the director of Y, something like the boss, right? So these are the kind of people to keep in mind. So anyway, so this is my talk. So you can think of it as velocity versus volume. We'll be talking a little bit about kind of bandit type models. This is a novel thing. So I'm kind of curious to get feedback on this. So if you think it's a terrible idea, or you think it's a great idea, or any kind of comments, feel free to reach out. I'd be really curious to hear them. So Act 1, tension. Data loop. So if you heard me talk last year, this is probably old news, and this is probably old news for a lot of folks. But so here's our mathematician, here's our boss. It says to personalize our sort models, right? So Expedia, we sort things. That's a large part of my job. We sort hotels. Try to get customers the most important things that they're most likely to be interested in at the top of the sort. So we must close the data loop. And so that's that whole concept that Alex was talking about earlier, right? So you have users that use the website. The website, you store some data. You use those data to kind of feed into your models. Those models predict what customers should be seeing, and then you hopefully create this feedback loop that helps improve the quality of your product for your customers. So we must close the data loop. So you ask the engineer, hey, can you close the data loop for me? Can you collect data on this new model that we're building? And he's like, great, sure. Well, we know that users traverse the website in a predictable pattern, right? We design it after all. So you go from click to click to click. There's a click stream. So a good way to model the data that we need to collect is based on the click stream. So we'll just log their clicks in context. So as a data scientist, the data scientist, Indara will come up and say, okay, I'm going to build my model. I'm going to start pulling in the data that you've selected for me, that you've started saving. Just say, colleagues, my code is taking a long time to run. How exactly is this data structured? So then the engineer comes to the room and starts talking blah, 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 JSON, blah, 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 Kafka, blah, 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 blah. So it turns out structured to a data scientist means a SQL table, right? So you think, oh, we're getting more data, sweet, append rows. But appending a row is a really complicated thing. And just to give you some concrete example, so a colleague of mine, really brilliant guy, wrote some Spark code using Python, right? And it took him, literally, it took the code an hour to compile before, like right when you hit go. It took an hour to start the code running. And once the code ran, it would run for 15 minutes, 16 minutes for 1 day's worth of data. Now, granted, we take that Python code and we smashed it up and turned it into Scala and did something good with it, made it smart. It took only a few seconds. But still, the point is, it's a lot of data. One, there's huge volume, but there's also tons of really complicated schema and setup. So in other words, yeah, closing the data loop is a complicated, terrible, terrible mess. It's similar to if the physicist is trying to put out the fire and you put a bunch of boxes in their way and they're trying to step over it, right? So closing the data loop is not as easy as your mathematician boss would have you believe. So why is it taking so long? Well, OK, the data loop is closed. But eventually, in Dara's smart, she gets it done. The project is done. And it starts running. And we start collecting data. We start running things. And then we run into another kind of observation. He's like, also, we're not recommending enough new hotels. Brand new, brilliant, awesome hotels that are brand new to Expedia, but we haven't seen them in the search results. Why is that? So the physicist was like, of course. This is another problem. And the model depends pretty heavily, right, on what it saw. Prior bookings, the hotels that were booked yesterday are a pretty good predictor of what will be booked tomorrow. But this is kind of a problem, right? The data loop induces kind of a self-reinforcing feedback. So if you have some bias in your data, that bias will be reflected in your model. So you need to be kind of careful about that. But Dara's a great data scientist. She's got a really good idea. So here's our Slack channel, right? Hey, Andy, can I hijack your Kafka stream? It'll be fine. It'll be fine. It'll be fine. Leads us to Act 2. Opportunity. So now that we've seen there's some issues, there's some tension with streaming data, talk a little bit about bandits and how they work. OK. So the boss man says, Greg says, hey, look, we need to combat bias in our hotel sort model. I've got an idea. Let's just push things to the top 10. Let's just expose one of these hotels that have never been seen by other people. Let's just push it to position 4, 5, 6, something like that in the top 10. That's what we must do. So he asked the data scientists, OK, so great, this is our problem. We want to select kind of the good new hotels to put in that position. How do we do that? Which hotel, what strategy should we employ? And there's a lot of strategies that you can use. You can pick them at random. You can try to guess which are the best based on your past experiences. And we've done a lot of these things in practice. And in practice, the only one of these so-called pinning experiments that have actually been conversion positive has been the multi-arm bandit. So what's a bandit? How does it work? So let's consider the following situation where you've got, let's say, 6 brand new hotels. There are other, for simplicity, let's just consider them to be otherwise identical, right? So the question is, we think they're identical. They may not be. Customers might like which one. Which one do we expose to the customers? What's our strategy for determining which is the best one? So the way that, so there's some fancy math that you can do, right? Some kind of Thompson. You try to guess, like, you make some prior assumptions, maybe because they all look the same, we start them out as flat, and then you try to, like, kind of assess, right? So you start collecting data. So the strategy might be, like, let's take Hotel A and we'll throw it into the, into that position and see what happens. And someone booked it, awesome. Right, so one show, one book, 100%, sweet. Now what? Do we go with A because it won last time for round 2? Or do we go with B, C, D, or E, or F? That's this kind of, well, A is a pretty good guess because it worked once, but maybe these other guys will work, right? So then you start having to make this decision at every round, every step. Do I pick a new one? Do I get better statistics overall? Or do I go with something that I know that works? And how do you, so eventually it's this process of, I guess you could say bandits are a framework for action, right? While you're gathering information. So there's a quick and dirty way, like kind of a textbook way that you can do, just in case you're interested in the technical details. You can set up, right, so this is this whole concept of like, well, roughly speaking, you plug it into some distribution that says wins versus losses, right? And it's kind of like the conjugate prior associated to this kind of like binomial distribution. Did it work or did it not work? And you can make things as complicated as you want them to be. And then at the end of the day, you kind of have to make an assessment. So these are a distribution of likelihoods to convert. And so you can say, well, let's just take the max. Like, let's sample the distribution for all the different hotels and pick the one that's the max, and then stuff that one in there and see what happens. That's a reasonable strategy to employ. OK, but the general theme, if you like here, is you're at this competition between two different ideas, right? You're either exploring the space of possible options, looking to improve statistics, or you're trying to exploit that solution which you know works, right? So a data scientist will turn it into kind of a mathematics design problem. And this is kind of related in general to information retrieval, right? So like you can talk about precision, like how accurate did I nail the thing I was trying to get from my customers, or recall, like am I missing anything? Did I make sure that I gathered the complete set of information? And so those kind of an overlap in those metrics too, right? But there's still some semblance of a conflict, and so this conflict is important to pay attention to. I would just like, so if this is a new idea, it's really easy to go out overboard and start thinking like seeing bandits everywhere, right? Especially because you're in the desert. It's cool, it's fine, it's a fun math problem to play with, but like, don't take it too seriously. It's not necessarily meaningful. It's just, what we're really talking about here is kind of a short time scale data loops where we don't really have any data, right? So the engineer comes into play. Cool. Okay. Act 3, the product. So this is the thing I'm pretty excited about. So we got tasked with a problem. So after dealing with all of this crazy data loop stuff for the past few years and realizing how streaming leads to some problems but can be used for some fun activities, we were posed with a problem that I was able to kind of utilize this information for. So consider the following. At Expedia, we're a platform, or a marketplace, suppliers, customers, right? So the hotels that we have, we're really also, we would love to make sure that our customers are happy, but we're also interested in keeping the hotels happy, because more hotels means more rooms. If we get the hotels like happy with us, they'll give us a better rate, more competitiveness, they'll open us more supplies, they'll recommend us to their friends, blah, blah, blah. So it's important to keep our hotels happy. And so if we can create a suite of services for the hotels, wherein we kind of do things for them, like revenue management, like basically help them improve their sales, help them do their job quicker, that means that Expedia is it's a bigger value proposition for them. So one attempt to do this, we had some product guys and some engineers got together and they built out this crazy platform, another platform, wherein it's basically, it's an advice platform. So any team at Expedia can come up with like a piece of advice formalized to like a card, right, that says, hey, you should do this. This might be do a promotion this weekend. This might be improve the quality of your photos on your website. This might be, hey, everyone else in your competitive set have raised their prices for this weekend. Looks like something big is happening. Maybe you also want to raise your prices. Some advice. The problem when you stack up all the potential pieces of advice from all the different teams at Expedia is, quickly the hotel owner becomes overwhelmed. So previously they didn't know what to do, and now they've got too much information, right? So that leads to decision fatigue and just a general bad user experience. They're going to leave the little web portal that we've developed for them, which is the exact opposite of what we want. We want it to make it clean. So can we curate this advice in a way that's like helpful? And can we do it at scale? And maybe instead of at scale, can we do it in a way that is programmatic, so that I don't need to know what's on those cards. I don't have to have some market manager somewhere sit there and sift through them for you. And just for some context, we started out with like 2 cards. And now we have 12. And in a couple of weeks, rumor has it that they're going to add 77 new cards from one particular team. So 2, 12, 77, hundreds. Soon there could be thousands of cards. We have no idea. And it's kind of a problem. Anyway, we'd like to curate the cards for clarity, help facilitate the decisions, and make a great user experience. Okay. So, fine, we want to do it programmatically. But what is a good card? What is good advice? This is a brand new platform, this is a brand new system, and I kind of sketched to you the velocity at which these cards are coming at us. So if anyone in the room is familiar with the bandit problem, right, it comes from this concept of a slot machine. You have a bunch of slot machines, which one do you pick? So the analogous situation in this case is you are constantly someone is just a truckload of slot machines are being added every moment, right? And you're trying to figure out how to handle this sword. So one way to think about it is, what are the other hotels using? So we don't have any data to start. It's a cold start problem. We have no idea what to do. What's the demand for a given piece of advice? Well, to start, we don't know. But we can ask the hotels. And the best way that we can ask the hotels is to ask for their interaction. So originally, you might imagine, like we kind of thought this system through as kind of like a Twitter feed, right? And so someone had the foresight brilliant to put a bunch of interaction buttons onto these cards. So not only do we get information about positive responses, did they click or not, but we can tell if they like them, we can tell if they dislike them, we give them the opportunity to kind of ignore them, a bunch of different ways of interacting. And so we can collect all of these different signals. And in fact, at the present moment, these are the only signals we have, right? So, but the point is that this kind of notion of advice design is now kind of a supplier problem. So like maybe your idea is a really good thing for the hotels to do, but if you don't frame it well, it's your fault, right? So we're just going to let what the hotels want dictate what the hotels see. Right? So this is kind of how this bandit thing is going to work. So yeah, again, what I was talking about, we don't really know offhand what the answer is to start. That's kind of the whole point of this exercise. But this is where those whole, where Andy comes in, where the short-term data loops takes care of it for us. Great. So I'll just walk you through a little bit of what we do. So we have these signals, and for the sake of complete, we'll just throw those out there. So what do we kind of do? We kind of segment them, kind of aggregate over them over some time window, and then take a weighted sum and kind of sort on the final scores. So for those, everyone here seems like an expert. I thought that there may be an opportunity for some folks to utilize some of the Spark they learned a couple days ago. So, but anyway, right? So some simple logic, and then you end up with score is some linear sum of likes and actions, and dislikes and snoozes, that sort of thing. But what is P? Right? So I'm not just aggregating and summing. That would be stupid, right? So what is P? What are we doing here? So P is the whole point of this exercise. P is what I'm really interested in. P is what I think might be crazy. So you need to let me know. Minus dislikes, sorry. Yeah, so good. Yeah, good catch, right? So some weights, sorry. Yeah, see, I played the mathematician a little bit. Yeah, it's just some number. Anyway, but yeah, good. So, right, there's some weights that they're in a map. Good catch. P imposes our kind of this explore exploit strategy, right? It's a probability distribution. So P is the fun part. So what is P? So I took it to be kind of a scaled Weibull distribution. Why a Weibull distribution? These are things from probabilistic reliability assessment for things where you don't know what's going to happen, like loss of cooling, accidents at nuclear power plants, like things that you hope don't happen, but you kind of have to model just in case, right? So the idea is it's kind of in this very similar kind of Bayesian framework where you have a probability distribution. So let's look at the blue line here. So suppose you have a card, it's brand new, nobody knows anything about it. You're very likely to draw a number close to 0 at the bottom, right? So you're very likely to draw something here. So it's a small number if your parameter that you're feeding in. So for the distribution of likes, if you're not a very well liked card, you don't have a lot of likes, you're going to get something small. But it's still a power law, so you're going to get a non-trivial response way out here sometimes. So it's effectively totally random. No scale, totally random. If you have a lot of likes, so the shape parameter, if you like, is this k value here. And so green means there's kind of a lot going on. That power law kind of smoothly maps to a Gaussian. And so eventually it becomes, and it just becomes more and more narrow Gaussian, much like a Poisson distribution or something. So you end up with something that's pretty close to 1. So that idea, there's some, we're scaling things here and whatever. But the point is that you change between something totally no scale, random, probably really small, to something predictably large. Right? And also, the benefit of this is it's super fast and super easy. You just import this object because Apache already put it in there for you. So you just have to put it in, spit it out. And so literally what we were doing is likes.sample, and I rescaled it a little bit. There's some kind of important to make sure the business logic made sense. We kind of had to regularize at the small values of the signal parameter. But the point is, each one of those terms draws from this probability distribution, so that at the end of the day, the sort is kind of stochastic, a biased stochastic. So just for a dumb example, here's some sample data, right? So you got a bunch of different cards, maybe A, B, C, D, E, F, G. They all maybe are from the same segment because you're sorting them together, so they better be in the same segment. And you've got a bunch of different signals, and these are the bunch of different, whatever. And so we somehow convert that into a score, but what's important is that the signals, right, that probability distribution is kind of drawn at runtime. So every time that the sort is applied, every time the model is called, it's a different response, right? Yeah, so in this particular instance, you get some sort, rank out. So D is the first, and does that make sense? Well, it kind of makes sense because they had a lot of likes and a lot of clicks, way more than anyone else. And you might have expected 2, this A to come in, but A came in third, but that's probably about right. So top 2, top 3, probably about right. But the moral of the story is that this sort is stochastic, but it's heavily biased. So we're doing that explore thing implicitly. So the nice thing about this problem is I don't have to just pick one card, right? I have to rank them. We're going to kind of truncate the suggested series at some point. So maybe you only take the top 5 or top 10. But let's say it's 10. You've got 10 cards. Maybe 2 of them are really, really important. They'll be somewhere in the top 4 or top 5. And the rest of them are all random. So you get this kind of exposure to the rest of the cards all the time while consistently showing, at least within the viewpoint of the user, a few of the so-called important cards. One more comment that I want to make on this idea is the other thing that's nice about it is aside from the fact that we start off with no data, and eventually we will get the data in aggregate that will be meaningful and we'll be able to do some better modeling. But at least to start, like, suppose that the cards that you start with are not really differentiable. Suppose that maybe 10 of them are they're all average and they're all pretty good. That feeds back into the outputs. So the output will still essentially be random. If there's really sharp focus on 1 or 2 cards, those 2 cards will definitely be to the top, right? So it really, truly depends on what the user behavior is. So I'm hopeful it's a good idea. Anyway, it was a fun exercise that led to a bunch of new ideas, at least for me, at least for the people I worked with. And so, people talk about the art of data science or whatever. I just wanted to point out, this is where the art happens, is when you, this process of struggling through something, through that process of struggling, you run into an idea that you kind of just put in the back of your head, and then you realize, I can do something with that later, and turning that later into a product. That's the art part of the data science. And some credits, some of the things that some of the people who worked on this team. Andy is a real engineer at Expedia. He built out our model deployment framework, so he's awesome. Leslie helped seriously with getting the pipeline set up. Fan basically quarterbacked all of it. And Phil's the big boss man, but he's a responsible guy. He'd put out the fire. He puts out a lot of fires. I talked to Brandon. I think I may have spelled his name wrong. Sorry, Brandon. But good guy. So yeah, I talked to him about bandits from time to time. Some other cats, and Mikhail from Qubel, who best solution architect ever. Cool. Thank you so much. So I have questions. Any feedback? Anything? Crazy? Good? Bad? Ugly? Silly? It's working for what it's worth right now.
How long have you been? When did you initiate this with the customers, and how long has this been in play?
The model has been running for a couple weeks now. So yeah. And the real trick is when we're about to get 77 cards added, just dumped on us. So that's gonna be the real trick. But the goal is to hopefully so I showed you 4 or 5 signals, but we can segment on the different types of hotels, and soon the amount of signals we can get is going to grow, or can grow theoretically. So now it's a question of balancing numbers of signals versus eventually hopefully getting a concrete data set. So one other thing I forgot to mention, and this is more bandit related. So at some point, I'm trying to convince the engineers to give me data about how the cards were presented to the customer so that I can get this concept of card at rank number 6 was clicked on, right? So one thing that I didn't give you a chance, sorry. I asked about those weights, right? And so the weights are, right now, they're kind of put in by hand now. Ideally, we'd like to feedback them and get to this kind of notion of a contextual bandit where every iteration that you show to a customer, you kind of is a step in your model training. So if we can get the rank at which a customer clicked on a card, we can feed that in through a hinge loss kind of thing and get some better feedback and make sure that we pick the right values of the weights.
Are there plans, so a lot of those is discovery, and
Yeah.
so after the customer picks, say a hotel or a card, are there plans then to go back, because I imagine you have a feedback for reviews, right? I can pick it, but I could have a terrible experience at the hotel or whatever, and I could then rate it really low, because
Yeah.
you gave me and then how do you tie that back in?
No, that's a really fair question. So let me split it into the card context and the hotel context. So for the context of cards, hopefully, and this is the only mechanism that I have for that at this point is the dislike button. So they can come back and say, God, I hated that. And so anything that comes, so the idea there is they're just kind of self-regulating in this context. So a acquiring data on whether or not the only thing we can do at some point, hopefully, is to tag cards in some manner that we can classify them. But this requires us to have more and more cards. And then we can say, well, cards similar to this card, this guy also doesn't like, so then we have some data. In that sense, that's good. In the hotel context, that's tough, right? Because they technically booked it. So if they booked the hotel, awesome. But we do feedback. So and this is where I don't take the bandit thing too seriously, but we do feedback information. If the hotel hated it, that feeds into the review score. That feeds into sentiment on what they typed on their reviews. And that is, it's not the highest predictor, but it is definitely a predictor for most of our hotel sort models. But yeah, fair point.
Especially if they're new hotels, they never ranked, they never put it in, right?
Yeah. Yeah, and that's actually, so another thing that we sort is activities, things to do, and it turns out something that's kind of predictive is the comments in the review, especially if it's a new kind of a thing. And so if you actually read the comment this sucked because of X, hopefully that'll dissuade other customers from buying in the future.
So but these cards are to your customer, the hotel,
right?
As opposed to, and so how do they? So I'm thinking if I'm a hotelier, if that's the right word, right? And
well done.
Thank you. And I have my portal into Expedia, and this card pops up, and it says, "Raise your prices."
Yeah.
And I go, "I like it." But what's the context that there must be something setting me up to understand what this, that there's some type of recommendation engine coming. There's some context around that card.
Oh yeah, so let's see if I can get this. So in terms of the engine itself, it's kind of on their front page. Here's some advice of things that you can do. So they come in every time, and that's what they see, and that's what they come to. And there's more of a story in that direction, but let's put that on hold for now. But in the case of the card, yeah, for sure. So there's a bunch of information on the card. Here's reasons why to do this. Quote. If you're a product person, right, reason to believe, that sort of thing. But then you click on that, and it takes you to the part of our web portal where they can perform that action.
Gotcha.
Yeah. Does that make sense?
Yep.
And hopefully, so for some of the instances, it's so for example, one of the cards might be your rates and availability are not comparable with another website like Booking.com, and then we'll go to the website that we already have, the page that's already set up that says not only is it down here, you're losing in sort this much, red alert, fix it. If you want, that kind of thing.
Close that loop, they come back and they hopefully say, "I like that card."
Yeah, if it helps.
And you feed that back into your.
Yeah, and so this there is a problem, right? With should that card not disappear? And at some point, because we do this kind of pre-filtering on the cards ahead of time, if it's relevant for the hotel or not. But you're right, maybe next time they see that card, oh yeah, thank you, I needed that advice because I forgot. It's usually what happens. And that's why we have that marketplace design infrastructure in place. Is hotels just forget that they need to update the Expedia prices too. And it's just kind of a way to nudge them to do it.
So I'm wondering if all your kind of clients, hotel clients, aren't equal in how much they visit the website.
Yeah.
Do you set up a weird sampling bias where most of this information is from your most active users? So you almost want to bifurcate or something like that.
Especially considering that our goal, that's a really good point, because our goal is to kind of improve the interaction rate, if you like, with different hotels to get them on, because the thought is, once we get them on board. And so this is where segmenting the different features comes in. We actually have the capacity to segment down. So what gets even weirder is it's not just hotels. So there's a notion of okay, so these cards are associated to this hotel, and so someone operating the hotel's stuff, but there's also this concept of a user. So a user could be more granular than a hotel. It could be the manager or the revenue optimization person in the hotel. And so cards specific to that person might be important to see. So that's what we're hoping to gain. But you also run into this problem where for chains, there could be a revenue optimization district manager for the Hilton for all of Arizona. And yeah, so how do we get that? That's tough. And so the hope is we'll win with segmenting, but metrics for there are definitely going to be increased, basically not just clicks, but completion of that cycle. But so that's one thing, and then the other thing that we should definitely look at is are we getting these other segments online? Number of segments is a really good idea.
Awesome.
Thanks, everyone.